All right. As people are still checking in and kind of tuning in, a couple things I want to do today. We have gone over right triangle trig. We've done a little bit of this trigonometry, and we've mixed together this, the Pythagorean theorem, and rationalizing. Okay. And this homework is kind of not the culmination of that, but it's a good like destination for now. All right. On the prompt that I had you answer in on campus, I asked you what questions do you have on homework, and these are the ones that uh, most people were asking about. Okay, so I'm gonna stick with these for now. Obviously, we can come back to this a little bit later, but we'll stick with 18, 16, and 20. All right. So we'll go over homework. Uh, then I will introduce uh, reciprocal functions. I'll give you guys the homework, and then we can start working on this. Okay. So nothing that we're doing today is really that different. It's just a slightly different equation. Okay. So it's all the same stuff. We're going to be doing the same thing. We're going to be rationalizing. We're going to be using the Pythagorean theorem, and we're going to be using a little bit of SOHCAHTOA. All right. But it's not super super different. All right. So let's start with number 16. And number 16 gives you this diagram. All right, and we're trying to find the tangent of theta. All right, and tangent is opposite over adjacent. And step one from the last class is just to determine what sides we have. Okay, so we can find the hypotenuse by drawing a line from the right angle to the other side of the triangle. And we can find the opposite side by drawing a line from our angle theta to the other side of the triangle. And then the other side is the adjacent. Okay, so right now we have the adjacent side and the hypotenuse, and we need the opposite side. Okay, so if we set up our Pythagorean theorem, we have the adjacent squared plus the opposite squared is equal to the hypotenuse squared. And then we can just simplify that and then solve for the opposite. So the adjacent side is 9, or the adjacent side squared is 9. 3 root 5 squared is 3 root 5 times 3 root 5. When we simplify that, we multiply the 3's together first. And then square root of 5 times square root of 5 is just 5. If we subtract 9 from both sides, we get that the opposite squared is 36. In order to cancel out this squared, we have to take the square root of both sides. And then the square root of 36 is just 6. So then our trig function is 6 over 3, which is just equal to 2. Questions over that problem? how do you get the 36? Uh, on this step, we have to get the opposite squared by itself, so we subtract 9. 45 minus 9 is 36. Then we take the square root of both sides. Okay, so that's 16. We'll do 18. Given this diagram, we're trying to find the sine of theta. And sine is always equal to opposite over hypotenuse. Okay, so again, the first thing we do is just determine what sides we have. So if we draw a line from the right angle to the other side of the triangle, we get our hypotenuse. If we draw a line from our angle theta to the other side of the triangle, we get our opposite side. Okay, so we actually have both of the things we need in order to finish this problem. Okay, so opposite is 9, hypotenuse is 15, and then we can simplify that. So 3 goes into both 9 and 15, so our answer ends up just being 3/5. Questions on that problem? Yep, that's it. That's why knowing SOHCAHTOA and what sides are what is very, very important, because sometimes you can skip a whole lot of work if you just know what you're talking about. Okay, so next we'll do 20. Which gives you okay, so 20 gives you this diagram, and you're asked to find the tangent of theta. And remember that tangent is always opposite over adjacent. So we need the opposite and adjacent sides. Okay, so next, we need to know what sides we actually have. So if we draw the line from the right angle to the other side of the triangle, that's the hypotenuse. If we draw a line from our angle theta to the other side of the triangle, that's the opposite side. And then the other side is the adjacent. Okay, so we have the opposite and hypotenuse, and we need the adjacent. Okay, so in order to find that, we set up our Pythagorean theorem. Substitute in what we know. And then start to simplify. And then once we have this equation where we have this left-hand side and then 100 on the right-hand side, we have to subtract 36 from both. So before I simplify this part, are there any questions on how I got anything so far? Okay. Now, in order to get just adjacent by itself, so we just want the inside of that parentheses. We don't want the squared. In order to cancel out that squared, we have to take the square root. And because we do that on one side, we have to do it on both. All right, so that leaves just the adjacent. And then the square root of 64 is 8. So now we have both sides that we need. So our opposite side is 6. Our adjacent side is 8. And then if we simplify that, we get 3/4. Questions on that problem? When you first start doing the Pythagorean theorem, do we have to label adjacent, opposite, and hypotenuse? I've been using letter variables like x. Uh, like, I like to stay consistent, right? So if we just define what terms we have, opposite, adjacent, and hypotenuse, I like to use those same things in the Pythagorean theorem. It's kind of up to you. I just, from my standpoint, in order to keep myself organized, I like to keep it as consistent as possible. So if anything, like I would use A, O, and H. But it's if you can stay organized and you know what sides you're talking about, that's totally fine. Like a lot of people will say hypotenuse is C, and then like opposite is normally Y, and then adjacent is normally X. All right, so you can do that. Um, I just like to stay consistent, especially when you guys are brand new to this and don't necessarily have a whole lot of experience. Okay. Are there any like other questions over this homework in general? I don't want to go over too many more problems, because we do have stuff to get over, and I do want to give you a little bit of time to work on IXL while I'm available to you in this class. Okay, so any quick questions on the rest of this homework? I just realized my mic was off the entire time. Okay. Um, so given a triangle, we should be able to identify which sides we have. So the angle opposite the angle theta, that's the opposite. The angle opposite the right angle, that's the hypotenuse. And then the other side left, that's the adjacent. Okay. And these sides, they have different relationships with different angles. Right. So the sine relationship, if we take the sine of angle theta, that's the opposite over hypotenuse. If we have cosine of theta, that's the adjacent over hypotenuse. And then the tangent of theta is opposite over adjacent. Okay. And we can use these relationships and the Pythagorean theorem in order to further understand those relationships. Okay. And eventually, we're going to get to solving for that angle theta instead of solving for any three sides. Okay. Now, there are three different trig functions that we need to know, and they're not as widely used, at least not yet. But they do show up quite a bit on the ACT, so we need to at least touch on them. All right. And they're called the reciprocal functions. And they kind of work the same way. They're just these trig functions flipped. Okay, so the reciprocal of sine, that's called cosecant. And the cosecant of theta is just the hypotenuse over the opposite. The reciprocal of cosine, that's called secant. And that's just hypotenuse over adjacent. And then the reciprocal of tangent, that's called cotangent. And that's just adjacent over opposite. Okay, and all the same rules still apply. You're still trying to find those sides. You're still trying to rationalize your fractions. It literally just flips the fraction and everything else is the same. So I'll give you like 30 seconds to kind of catch up, and then we'll go over a couple of examples of these. Okay, so first of all, your homework tonight will be R2 on IXL. All right, and it's again, it's just like the trig functions that we were just working with. Um, it's the same concept. The fractions are just flipped. All right, so sometimes you got to rationalize in a couple of different places, but it's mostly the same. All right. There's also there's another worksheet that I put up into our topic section of right triangle trig um, that has a bunch of examples of this stuff. All right. So if you go to topics, go to our class, go to topics, go to right triangle trig. We're on this trig ratios reciprocal functions. Okay. We're going to get to inverse trig uh, probably next class, but right now we're working with trig ratios, reciprocal functions. And if you click that, there's a worksheet with a whole bunch of examples that you can at least verify your knowledge on. Okay, one of those examples, this is the very first one, gives you this diagram, and it asks you to find the cosecant of theta. All right, so all the steps are still the same. We still want to identify what sides we have. All right, so if we draw a line from theta to the other side of the triangle, that's the opposite side. If we draw a line from the right angle to the other side of the triangle, that's the hypotenuse. And then the other side left, that's the adjacent. All right, and cosecant will always be hypotenuse over the opposite side. Okay, so we have the adjacent and hypotenuse, but we don't have the opposite, so we need to solve for it. Okay, and this is where it becomes a lot like what we were doing before. All right, so if we set up our Pythagorean theorem, and substitute in what we have, we can solve for our missing side. Then if we subtract 36 from both sides, opposite squared will be on its own. And we'll have 28 on the right. Okay, so before I go on, before I actually solve this, are there any questions about what I've done so far? Okay, so then once we get there, we have to solve for just the opposite side. So we have to get rid of this squared. In order to do that, we have to take the square root of both sides. That leaves us with just the opposite. And then we have to simplify the square root of 28. All right, so I know that we can simplify the square root of 28 as the square root of 4 times the square root of 7, which is equal to 2 rad 7. Okay, so then we have our opposite side. we can plug it into our trig function. Okay, but our answer has a square root in the denominator, so we have to rationalize it. And in order to do that, we have to multiply by rad 7 on both the numerator and denominator. When we do that, 8 times rad 7 is just 8 rad 7. And then 2 rad 7 times rad 7 is just 2 times 7. Which we can then simplify. Okay, so that's, again, this is exactly like the same thing we've been doing. All right, it's determining your sides, finding the sides that you don't have, plugging it into our trig function, and then rationalizing and simplifying. How'd you get 2 over 7? How'd I get 2 rad 7? So I'm guessing you're talking about here. So we get that the opposite is the square root of 28. Okay, 28. We have to factor out a perfect square. All right, so if we 4 goes into 28, right? 4 times 7 is 28, and 4 is a perfect square. So we can rewrite the square root of 28 as the square root of 4 times the square root of 7. And then if we simplify the square root of 4, the square root of 4 is just 2, and then rad 7 stays there. Does that clear it up at all, or does that not make sense? Again, when we're simplifying radicals, we're trying to factor out perfect squares from what's underneath. And those perfect squares, the square root of perfect squares, are just numbers, right? The square root of 4 is just 2. Okay. Um, I think this is, again, this is pretty much the same thing that we've been doing. So I'm going to let you get started on the homework. The homework is R2 on IXL, and it's up to 100, and it is due on Monday. Okay. So I'm going to let you get started on that. I will be in Teams in the next like minute or two. I'm going to leave this open for the next like 30 seconds to a minute. And as you have questions, you can ask them broad questions you can ask here. And then you can ask a little bit more specific questions once we get to Teams. Okay, so I'll leave this open for a minute or so, and then I'll head over and start a meeting on Teams. Okay. So I'm going to close this. I will start a meeting on Teams, and if you guys have more specific questions, you can ask there. All right. So I will see you there in like the next minute or two.